So, hello everyone. In the last video, we have seen that the all kind of radiations happening in photoelectric effect. All kinds of energy radiations or emissions are having very special characteristics. If I just try to summarize them, our last day's work was that energy of electrons were dependent on frequency, not on intensity. Clear? Second thing we got that there is a minimum requirement of frequency which is known as cutoff frequency. Below this frequency, no radiations can occur. Below this frequency, no radiations can occur. That is why it is called cutoff. Means if you go below this frequency, there will be no radiations or no photoelectric effect. That means you are cut off from getting any kind of photoelectric current. Now, one more thing is that if you look at the photoelectric effect, it is instantaneous. Starts in the time range of 10 to the power minus 8 second to 10 to the power minus 9 second time. Clear? So why did I just mark these things? Means in a special reasons? Yes. We've taught that last day that first of all, according to our wave theory, all kinds of energy, might be light, might be sound, travels like waves. Means if you are looking at the photoelectric effect, the light is coming outside from an incident source and it is falling on the plate just drawn in the last diagram, and due to the energy carried by that light, we got emissions of electrons. Now these electrons were having some kinetic energy, and in the opposite side we gave some potential. If we gave a similar kind of potential, means for electrons if we also give negative charges or negative potentials, it repulsed, and from that thing we got the calculations of stopping potentials, which gave us the idea of kinetic energies, and a lot of calculations we have done there. The problem is that the energy we find out was of frequency, not of intensity of the light. Intensity of the light means it is not a function of amplitude. In the last day we have drawn the energy diagrams of a wave and found out that a wave with higher energy is basically having a large amplitude. Any wave whose amplitude is higher means its energy is higher. Then why an incident radiation of higher amplitude, which will cause higher intensity, will not give more energy? Secondly, minimum requirement of frequency means below that frequency if I give high energy waves, high amplitude waves, no radiations are occurring. Why? That means the energy is not depending on amplitude or intensity. Intensity is amplitude square, I hope you remember, and it depends on frequency. And thirdly, and very importantly, instantaneous. Usually what do you think? That inside the surface there are multiple electrons are present, and they are in that surface because of one attractive force which we call surface potential. If my incident radiation, that is a light, gives the energy to the electrons more than surface potential, then these electrons comes out of the surface and travels with that energy, that kinetic energy portion. As per the wave theory, this incident light which will energize these electrons, how they will give the energy. Now they comes like waves. This transfers energy by creating vibration in those electrons, which vibrations will lead to make them free electrons here, and those free electrons leave. Now for this wave energy going to the electrons, and electrons are absorbing that energy in a continuous way. Remember, wave theory tells that is energy absorption is happening continuously, happening in this continuous way. Basically will take a little amount of time, around 10 to the power minus 3 seconds order, around this time 10 to the power minus 3. But we find out that it is happening instantaneous in a time range of 10 to the power minus 8, means it is 1 lakh times faster. So wave theory cannot explain why this is happening so fast. That is when we come to the Einstein. Before Einstein's work, there was a scientist named Planck. Full name Max Planck. On 1900, 14 December, he gave a very special theory, which actually is a cornerstone of quantum physics. Basically quantum physics. He said that during his explanation of black body radiation, this topic is very much unknown to you, I know. Black body is a substance which can absorb all kinds of reactions, and if you heat that substance, all kinds of reactions will come out of that object. Such an object is called black body. Now when its energy graph was studied, there was some problem in explanation, which you will learn in higher classes. For now, you have to understand that Planck said that we were thinking that this kind of energy transfer, means any kind of energy which is always traveling like a wave and is always moving continuously, it is absorbed continuously by a substance, and if I heat it, it is radiated continuously by a substance. This is not happening. This thing is not a continuous thing. Nothing happens continuous. Rather, any kind of energy, no continuous. This continuous nature is not happening. What basically happens? Now, energy or any kind of form, in any kind of form, does not travel. If you are talking about light energy, if you are talking about heat energy, any kind of energy basically travels in quanta. That is also the origin of the name quantum mechanics. But you are getting surprised what this word quantum mean. Quantum means a smallest portion, a small packet. So I think it's a Latin word or Greek word, I don't remember properly. The word quantum means a small packet or a small portion. Means all these energies are not continuous, but they are discrete. Any kind of radiation happens like this. They happens in small discrete parts. They are not happening continuously. And any kind of absorption of energy happens in discrete. All kinds of radiation also happening like this quanta. That means in small portions. You can see they are not continuous like this, they are discrete. They are discrete, that means they are separate. Clear? And this is how energy is traveling. This is the method of energy traveling in physics actually. So how much energy is taken by each quantum? We all know that any kind of energy has an intrinsic quality of which is called frequency. Energy of a single portion or a single particle is proportional to this frequency. Is proportional to this frequency. This frequency is symbolized by this nu. The pronunciation of this one is nu. This symbolizes frequency. In this proportional relation, we get a constant h. The h comes at constant, which is, according to the name of Max Planck, is called Planck's constant. The Planck's constant is a very important quantity in physics. You must need to remember its value throughout your life whenever you are going to work with physics problems. This value of h is 6.6 into 10 to the power minus 34. You have to remember this thing. Clear? And the unit is joule into second, joule second. Clear? Clear? This is the unit you have to remember. So all this one, if their frequency is nu, each and every part is carrying energy E equals to h nu. Each one is E equals to h nu. This amount of energy will be carried by each block, each segment, each quanta. And if radiation is also occurring, it will also happen in small packets of E equals to h nu. Clear? And this is the basic thing that Einstein also implemented Max Planck's idea in case of photoelectric effect to explain all these phenomena. Let's see how. First of all, he said it is very simple now that energy transmission is happening in terms of quantas. Clear? So each and every part is having E equals to h nu amount of energy. So you can see energy is proportional to frequency and not on intensity or amplitude. So this is what solves our first problem. Our first problem was the energy of the electrons were dependent on frequency, not on intensity. This first problem is solved by this method or by this assumption in quantum physics. Next problem was what? The next problem was that there is always a minimum frequency below which no energy emissions are happening, which was called cutoff frequency. It's very simple. In a surface, electrons are present. There is always some minimum energy required to take these electrons out. Just like I hope you remember the bond energy, the minimum energy required to break the bond. Similarly, it is the minimum energy required to break these electrons out of this surface. To take these electrons out, and that energy is called work function. Clear? If I mark that nu 0 is the minimum frequency at which radiation starts, means nu 0 I am referring to the cutoff frequency at which the radiation starts. Then if this is cutoff frequency, then what is the energy corresponding to it? W equals to h nu 0, because E equals to h nu. If the value of nu is nu 0, then work function is W equals to h nu 0, and this W refers to the value of work function. This is how we calculate the minimum energy required to take the electrons out of the surface, and that is why below this frequency, means below this energy, the electrons are not going to come out. Third problem. I hope you remember what is stopping potential, that if we apply negative voltage in the front terminal, means electrons were coming out of the surface after light came out, and in the front surface if I gave negative potential, the electrons were going to stop because of the repulsion, and the potential at which this happened is called the stopping potential, Vs. You remember this thing? You remember that if I increase the frequency, then again some electrons were able to reach there, but if I increase the intensity, there was no more electrons reaching there. Why? Because if I increase the intensity, number of quanta, number of amount of energy coming, but the energy carried by each quanta, which is E equals to h nu, that depends on frequency. So if I don't increase the frequency, each of the quanta is not carrying more charge. If the frequency is same, the energy carried by them is also same. So they are not able to give the electrons more energy, and the electrons are not able to break the stopping potential even if I increase the intensity. But if I increase the frequency, then this energy increases, these electrons also come out with greater energy, and they are able to reach the surface because they are getting more kinetic energy from it. This explains why the stopping potential thing depends on frequency. That means kinetic energy of the electrons depends on frequency. And the last and not the least, the instantaneous nature. Why these things are happening instantaneous? Why this 10 to the power minus 8 second to 10 to the power minus 9 second? Why electrons are coming out of this surface so fast? Because as per a wave theory, we were taking extra time. Why? When the waves were coming in, they are giving energy to these electrons. The electrons start vibrating at first, then they got the energy, then they come out of the surface. No, this is not happening. What is happening is that energy is not coming like a wave, it is coming like a quanta. And when each one quanta is absorbed by an electron, it instantaneously comes out, because energy absorption is also happening in quanta. So if I just giving in a small portion, then that small portion is absorbed at once, and after absorbing that portion, the electron also comes out at once. That is why it is happening so fast, unlike the wave theory. That is how we can explain the instantaneous problem of this. So this is how Einstein solved this problem, which gave him the Nobel Prize in Physics. So this is what we will learn about the photoelectric effect. Now we can also draw and find out some graphical explanations here. Just like, first we will learn about the energy relation. First of all, you know, the quanta of light is bringing the energy E equals to h nu. How this energy is expensed? One part is going for work function, that means to take out the electrons, and the rest of the part becomes its kinetic energy. Now this work function is h nu 0, like we calculated. So h nu equals to h nu 0 plus kinetic energy. What is the equation of kinetic energy? If mass is m and velocity is v, then half mv square. So h nu equals to h nu 0 equals to half mv square. So I can write half mv square equals to h nu minus h nu 0. I can take h common, nu minus nu 0. So these are all energy equations. One equation is this, higher equation is this. If I change sides, this is also the equation of energy. If you are asked to represent in wavelength, what is the way? I hope you know the formula of waves, that velocity equals to frequency into wavelength, means v equals to f lambda. You remember that formula from light? In case of this photoelectric effect, we are checking out this quanta. Quanta of what? We are actually focusing on quanta of light, means small particles that carry the light energy. They have a beautiful name, which is called photon. Now this photon particles travels with the velocity of light. So v equals to c. Frequency f is actually not represented by f but given as nu. We have seen in this expression, and lambda is lambda. So instead of previous wave theory equation, we use this equation in our work. Clear? Now c equals to nu lambda. So nu equals to c by lambda. So we will use this h into nu will be replaced by c by lambda, and nu 0 is c by lambda 0. Clear? This is the expression of half mv square. What can I do? I can take c common. So hc into, I can take c common, then what I am getting? hc into 1 by lambda minus 1 by lambda 0. This is also an equation of energy, but in wavelength terms. I am writing freshly here that half mv square equals to hc into 1 by lambda minus 1 by lambda 0. Why lambda 0? Now lambda 0 came from nu 0, c by lambda 0. Then lambda 0 is called, just like it was called frequency in cutoff frequency, it is called cutoff wavelength. So these are all energy equations. Please remember this equation, note down in your copies. This will be required for your further calculations of numericals. Now more further, if we go, we can also draw a graph to determine the value of the Planck's constant. We got in the energy equation that half mv square equals to h into nu minus nu 0. Now how did we determine this kinetic energy? I hope you remember the kinetic energy was determined by that how much potential can stop the particle. Means one electron is coming out with some kinetic energy. If I give equal amount of repulsion force by the potential Vs, then the electrons are getting stopped, then this value and this value are equal, that is why they are stopping each other. So that is why this was called the stopping potential. And if I know what is potential, potential is the work done or energy per unit charge. So work, or basically it's also term of energy, is potential into charge, and this work is equal to how much we need to stop this kinetic energy of it. So this is also equals to the kinetic energy of it. This is why this kinetic energy half mv square is also given as potential into charge. Charge of an electron is E, potential is stopping potential Vs, so E into Vs, EVs. Clear? So if I plot this value in our graph, so this is stopping potential we got. So you can write, if I give the substitution in here, that EVS equals to H into nu minus nu 0. I'm just substituting this value instead of v square in the equation 1, and we get this. Clear? So what is Vs? Vs equal to E comes here, H by E into nu minus nu 0. So if I just plot a graph of this, H by E into nu by H by nu into nu 0, what I will get? I can calculate the value of H by E as a slope. Means you have to plot a graph of this Vs versus nu. The slope will give us H by E. We will get a straight line from this graph, where the negative portion signifies this negative part and the positive portion signifies the positive portion of this. If we calculate the slope here, the slope of delta y by delta x gives you H by E. So if you multiply the slope by E, you will get the value of H. So this is how slope into charge will give you the value of Planck's constant. Means if it is ABC here, if I just try to mark out these things, so what I will get, this AB part by BC part, that is the slope, is equals to H by E. So H equals to E into slope, that is E into AB by BC. This is also how we can determine the Planck's constant graphically. Clear? This thing is not much important to find out using the graph. Sometimes some questions are coming from it. Now we can go to an important and very interesting topic that we just declared, that each and every kind of energy radiation is having some particles in it, and that particle is called its quanta. In case of light, that quanta is photon. We can calculate the energy and momentum of photon. Energy of photon, how can we calculate? Very easy. You know Einstein's energy equations, E equals to mc square, and we got E equals to h nu is the energy of photon. So I can write h nu equals to mc square. I'm just equating these two, h nu equals to mc square. You can also calculate the m like h nu by c square. It might not be the mass, and this is called kinetic mass of photon. Kinetic mass, the rest mass is always 0. And you can also calculate further things from here, the wavelength, sort of things like this. This can be also, say, nu can be written as c by lambda, so it can also be written as h by c square into c by lambda. C here cancels, h by c lambda. This is also one more equation of it. If you are asked calculate the momentum, these are all energy equations. Momentum is what? Mass into velocity. This is called momentum. What is mass? H by c lambda into velocity is c. C cancels, h by lambda is the equation of momentum. If you put lambda as c by nu, it is also hc by nu. It is also the equation of momentum. So I hope you understood it. Equations are important. Thank you.